Post-lunch sessions are very interesting, not for the presenter, trust me. But I'll try and make the max out of your attention, how much ever I can get it. So I hope you are coffeeed up or teed up. My name is Ravi. I lead the systems engineering organization for emerging markets at Commvault for about 104 countries. It's such a great honor to be here. It's not my first time in Kenya. And what I hope to share with you today are certain perspectives around infrastructure of trust. This means so many different things to different people. And in my brief presentation and showcase today, I'll share with you my perspectives. I have worked for a bank on the IT side. I have received that 3 a.m. call that questioned the trust within the data center. I've lived through those days. I've designed some very complex data protection and cyber recovery outcomes for different industries, banking, oil and gas, government sector as well. So what you'll see in my slides might appear prescriptive, and it's intended to be that way, because that's the message I want to leave you with. Let's get this working. Just bear with us on that one, please. While they sort out the batteries in that device, the clicker, let's quickly run you through how I see infrastructure of trust in today's age of AI and data. AI, you would have heard so much from so many different speakers today, is really all about trying to have business support, decisionality support, and eventually rushing towards decision automation. Now, that's not easy. If you're a bank, that means you need to score some of your customer credits and everything that goes on in the world of accounts to make a decision if a prospect to whom you want to lend money to is creditworthy or not. Now, what if a computer or a grid of computers makes that decision on behalf of a credit analyst? What if it's not one person? What if it's thousands of companies that are applying for credit from a banking organization? That's a use case in the world of finance. AI in the world of healthcare means X-ray machines, CT scans being analyzed, again by software and hardware combined, to figure out if certain nodules in a brain scan or a lung scan actually represent some form of cancer. And then providing the radiologist enough information so the decision about the patient can actually be done in a, let's just say, controlled manner. It's helping a healthcare professional achieve the objective. AI doesn't mean the batteries in a clicker work every single time. I learned that today. And hopefully colleagues who come in after me would have the privilege of using it. Take your own time. Coming to data in the world of AI. First thing, any C-level entity, CIO, Chief Information Security Officer, CEO, etc., need to really conclude on is, what does data mean for me? How am I using it? Where is my data gravity? Is it on-premise? Is it in the cloud? Or is it hybrid? And in that case, I need to make sure we have the right building blocks to protect and defend against infrastructure destruction, against data wipes. How many of you have heard of ransomware in the room? Just rough raise of hands. How many of you have heard of Viperware? Viperware with a W. Hermetic Viper, Isaac Viper. No? That's the work of state actors. And here comes my savior. Thank you so much. You saved me from a lot of embarrassment today. I appreciate it. The world we are living in, especially if you are serious about AI and achieving business and governance transformation, depends on how the C-level protect data. So what are these folks doing? I discuss these insights with them week in, week out across the several markets that we operate in. The three things that CISOs drive, and I'll come back with the data gravity question. The first and foremost is application stack resilience. Now, application stack resilience really means if my organization depends on data, data is consumed by applications, end users leverage apps for specific outcomes. So I need to have a level of resilience if I'm serious about achieving organizational uptime. If I'm serious about achieving something known as survival time objective. Anyone here heard of survival time objective? STO. New concepts, right? It's the net time taken from total destruction of a cyber attack, total destruction of your AI systems, your data capital landscape, everything that you know about your organization, right to you restoring, repairing, rebuilding, and relaunching your business apps. So, Phoenix rising from the ashes. That's what's it about. So this is where CISOs are really investing a lot of their time into, getting application stack resilience right. They're also doing something in the space of infrastructure resilience. This is your typical firewalls, your antivirus, anti-ransomware, traditional products. Traditional and then not so. The funny thing is, if you focus on app stack and infrastructure resilience only, you haven't really achieved your objective as a data practitioner. You've got to be able to move and pivot heavily towards something we call data resilience. Mapping out your data capital landscapes, doing it consistently in a well-defined fashion, obviously. Figuring out the value of the data so that you don't fall into a mathematically non-probabilistic problem where recoveries are simply not possible. And because this session's about frameworks as much as it's about data and governance when it comes to the world of trusting what you have and being able to deliver services, I default to a framework such as the NIST cybersecurity framework, the 5 famous pillars. Every tech practitioner knows about them or has heard of them. Identify what you really care about, pillar number 1. Protect, detect, respond. Protect what you got, detect all the threats, respond to a risk turning into a threat. But the 5th pillar is really the most interesting one. Recover. Recover yourselves, everything you know from a data perspective, on-premise or in the cloud, consistently, and by the way, within that famous phrase, within your survival time objective, STO. So your first mission when you go back, if you are into government, into a telco, or if you're a bank, knock upstairs and ask the question, what is our STO? Who's responsible for measuring our survival time? Do we know if we meet it or have we breached it? What's the evidence thereof? So some interesting learnings. And if you are into mapping out critical infrastructure dependencies within your organization, in this slide, I showcase the government entity angle. I have similar slides for different kinds of industries, oil and gas, non-government, banking, and telcos. As you would see here, you have to map out what are your critical assets, dependencies, and your STO. You then need to have those really identified with data custodians known. Whom amongst you are into system administration and IT planning in the room? I'm just curious. Few folks in the back. Anyone from the world of financial and FinOps? Cloud? Okay, we got a good mix. You got to be able to figure out where your data lives and what that actually means while you link together these dependencies to repair your organization's systems. But more so, you got to define survival runbooks, things everyone needs to do, including system owners and administrators, including data custodians, to be able to regenerate your minimum viable business. So, survival time objective, which is very key, minimum viable business, and then all the resources tied together to deliver the objective. But then again, let's layer in a whole fabric of resilience across the board and see what that actually means. If you have an AI landscape within your enterprise, if you are leveraging several types of infrastructure that you must protect and defend against different kinds of cyber attacks, this leaderboard, so to speak, captures at least a half an hour talk track of things organizations must do to remain viable. And it's not easy. There are things one must do to identify risks. There are things one must adopt to basically leverage advanced techniques like deception. And in the world of AI, it's not just about destruction of data or elimination of computer nodes. It's about data poisoning. You see, in the world of AI, where decision support and decision automation is backed by millions of parameters working together to help computers identify insights and then act on them, to put it very, very simply. If the parameters themselves are modified with the intent of influencing a decision one way or another, then that means you've got a data poisoning attack, which means you can't really rely on your AI infrastructure, on your investments. And some advanced state actors have even figured out how to poison the source on which the AI decisionality and the processes depend on. It's just a matter of manipulating a few parameters to achieve that objective, and it's not easy to detect. It's like I ask you, you are the famous mayor of the Japanese town of Fukushima. Heard of the nuclear meltdown in Japan many years ago? The Fukushima nuclear disaster? Of course, some of you have. You're the mayor, you're told you have two choices. Choice number one gives you an alert 3 minutes before the tsunami hits your town. 3 minutes. The other choice is you're given this magical solution that gives you an alert 3 weeks before the tsunami hits you. Which one would you go for? I would go for 3 weeks. Don't ask me why. I would like to save some lives. That's early warning. What if in the world of AI, I have this capability to trap bad actors in their advanced scanning and manipulation effort weeks before they actually poison my data capital landscape? Welcome to the world of cyber deception, where bad actors lured into banking networks think they are actually attacking ATM machines, but they're not. They're actually playing with a little lure that we created, that we know how to manipulate and present to a bad actor and trap them in action, while we can protect everything that's happening in the background. That's the world where you get several weeks of advance notice and the ability to figure out the tactics and all the tools that these bad actors leverage to impact your outcomes. How do I then test all of it? if I have certain regulatory headaches that I need to address. Welcome to the world of clean rooms, and I'll talk about it a little later. You've always got to figure out if there are anomalies, because my session's been titled Infrastructure of Trust, for Trust, in the world of AI and data. The best kind of trust is trust nothing, trust no one, basically live the world of zero trust, verify every single data access and system manipulation, verify every login, every change, and always be detecting anomalies. So this slide talks about it from a recoverability perspective. Now, moving into a more prescriptive way of looking at things, the architecture to be able to defend your minimum viable business, your minimum viable applications. As I mentioned, the best kind of trust is no trust. Absolutely nothing should be assumed or implicitly allowed. So in this scenario, where organizations, banks, governments, and telcos are protecting a lot of their data with the pure intent of recovering after a cyber attack, well, to the left-hand side, that's you. That's an extremely chaotic environment. Now, picture this. You're in a math class. Who enjoys mathematics? Factorials, permutations, combinations, anyone? I'm the only freak here on stage. There are n number of permutations and combinations and processes running in production environments. Not to get too technical here. N with an exclamation mark, n factorial we call it. If there are 1,000 different things going on in production, that's 1,000 factorial. Guess what? That's trillions and trillions of combinations of things in production that you now need to sift and figure out if they are safe, agreeable, and allowed. Do you have enough computer resource and brain power for that? I don't. So how do you figure out what you need to do? You need to handle the problem on the left with something smarter, something more different. And that's the world of isolation and air gapping. In this scenario, you take whatever happens here to the left-hand side, you seed it inside this little area, which I like to call a cyber vault, where we then look at the quality of the data, the DNA of the data, to conclude if this can be trusted or not, or if actually it contains some form of corruption. This is an ultimate defense strategy because, ladies and gentlemen, if anything on the left-hand side has been compromised, then you would depend on a golden copy on the right-hand side and leverage that to regenerate your entire infrastructure, including your AI data capital landscapes. And along the way, we have had the good fortune of working with many, many industry organizations, those who issue certificates of compliance, and those who mandate information security lockdowns. Some of them are from CIS, obviously, similar to NIST. Some of them are FedRAMP. FedRAMP happens to be one of the most stringent cloud and on-premise regulatory authority in the West. There is the FedRAMP and then there is the StateRAMP. What we've done is we have done a lot of work across the board to meet different kinds of certifications. HIPAA for healthcare, for example, PCI DSS in the world of finance. I spoke about FedRAMP already for government services. So one learning that I request you take back is please study those regulatory aspects and take the best out of those for your specific context. And in doing so, I want to share with you that we were able to cross more than 400 different gates of security when it comes to FedRAMP. We are the only ones as Commvault who are actually FedRAMP High certified. But that's a side point. It's the work and the rigor that we have put in over the last several years. Coming to the subject of verification and ensuring you are capable of regenerating your setup, including your AI landscape, in a zero trust method, disaggregated from your chaotic production setup. Welcome to the world of Clean Room, where we take a golden copy of your data and we spin it to verify, validate, repair, rebuild, and prove that it works the way it's supposed to. This is how we tie together a fabric of cyber resilience across all the pillars of technology, infrastructure, data, and dependencies therein, so that you don't need to think of the famous or rather infamous question now whether I can basically ensure I can achieve my survival time objective as a business. Again, boils down to one key thing. How do I size this beast? Where do I run it? You don't need to run this particular technology on premise. You can actually consume it directly in the cloud within minutes of subscription, and you can bring up your services in a very controlled manner within your survival time. That's the whole mission. And then what do I do once it's up and running? Well, bring in forensic experts if you want to. Bring in AI and data analysts, or better yet, use our tools to prove to your auditors and your regulators that what's been recovered is actually reliable. That's the whole idea of achieving cyber recovery in today's world, where you are required to hurry up, test new technologies, but at the same time validate what you got as recovery copies. Talking to your enterprise risk division, ERM is the very famous tool set within different organizations. The ERM tool set actually tells you all the kind of risks that you need to worry about, including residual risks, including endogenous internal risks and exogenous external risks. Map them out. The next pillar would be the readiness pillar, where you are constantly hunting for threats within your AI infrastructures, within your data capital landscapes, with the tried and tested capabilities and machine learning to figure out what really goes on will impact you from a recovery standpoint. So that's risk and readiness. The third pillar, finally, recovery, rebuild, restore, relaunch, the 4 R's. India itself. Spin up your critical workloads in a clean room from an air gap environment. Spin up your critical workloads in a clean room in a controlled environment from an air-gapped domain, which has had an attack surface of exactly 1, so you don't fall into the n factorial math problem. Because, ladies and gentlemen, in today's world, throwing more security tools at the problem is not going to help you. The bad actors have AI. They have exploits that you haven't even heard of. They can crack into the most secure database structures in no time, because there are vulnerabilities within systems and exploits that go in for a few $10,000 all the way to 7 million plus. I'd encourage you to even read a book by Nicole Perlroth. She's a New York Times bestseller. The book is very nicely titled, "This is How They Tell Me the World Ends." That's the title of the book. And the author is Nicole Perlroth. She explains the kind of vulnerabilities and cyber exploits out there. So who are we to assume that we are secure when you are required to leverage AI for betterment of citizens? You got to be very careful. While you might hear from a few tech providers and vendors being very prescriptive and they have the obligation to do so. But when you stitch together best practices from across the board, you got to ask yourself the question, the value that this adds. So with exploits and vulnerabilities, trust nothing, trust no one. Layer out a fabric of resilience that gives you full control over your data landscapes, no matter where it lives. What we have done in Commvault is we give our customers that singular dashboard with observability and feature sets which deliver value across these three boards, which is identify the risk, ensure there is readiness, including deception, and preparing the clients for restoring, rebuilding, recovering, and relaunching their business critical applications. Thank you so much for hearing me out and for the perspectives that we are sharing with you today. I just hope you found this useful and you would be able to use some of it in your organizations as you go forward. Thanks again.